Hello, and welcome back to our video series on the Nanoindentor. Today we're going to be looking into placing our samples into the Nanoindentor and performing tests on it. Just to review, I mounted two samples in the last video, some HDPE and some metal samples, using either crystal bonding mounting or powder mounting. There's just a few things that we need to do first before we can enter them into the machine, so let's get at it. Moving over to the computer now. First, let's double click on the InView application and let it load up. Just takes a couple moments for it to fully load everything and whatnot. Alrighty, and then we want to make sure that we put up dynamic indentation, constant strain rate, drift selection. And here we are now. Now, going over to this section over here, you want to set the active profile. Essentially, this is where the computer will just save your information and data for each set. So, I'm already listed on the system over here, but if you're not in the system, you can very easily just press add new over here, and then it'll allow for you to pretty much set your own name to whatever you want for it to be, or whatever you want for the computer to save your data under. Alrighty, so I'm just going to just press enter there. Put it back on me now. So to set the machine into the loading position, we're going to press on this go to load sample button over here. It is very important to do this, as manipulating the machine in any other position has a high probability of damaging the tip, which is a very costly affair. Now, to calibrate the samples onto the magnetic sample tray, you'll first want to place the samples onto the tray and just very slightly tighten it. So what I'm going to do is place that there, place that right there. It's very, very slightly, just enough to barely hold it in place. And now what you'll want to do is you want to find a clean sheet of paper. And so what you're going to do is you're going to place your sample tray upside down on it. So pretty much what this sample tray has is it has little standoffs here that we're going to be calibrating all of the heights to make sure that we don't have any errors when we're taking data and whatnot, and the machine knows exactly what we're going to be doing. So what you're going to do is you're going to loosen all the samples that you just put into there. And then make sure it's nice. Just make sure it goes down as far as possible, and then tighten it as far as it can go. Alrighty, now that they're all tightened, what you want to do is you want to make sure that you just double check with your eye, make sure that they look to be right at the level that they're supposed to be, right in alignment with the standoffs. Yeah, these look all pretty good. Now that all the samples are properly mounted, we can place it back into the Nanoindentor. Before you place the sample mount into the Nanoindentor, you want to make sure that you have the proper surfaces contacting each other. So a really easy way to look is you'll see that there are little magnetic pieces on two of the sides. Those two sides are the ones that align with the sample mount over here. And what you'll also hear is you'll just hear like a small click, making sure that it is fully stabilized and it will not move. Going back to the computer, we'll want to start calibrating the sample surfaces so that we make sure that we're performing tests in the right areas. Notice the location buttons over here. In this section, you can use any of these buttons to quickly go to different samples that you have on different mounts. So currently, if you look at our feed over there, you'll see that we're on top of puck number 2, which is fused silica. Typically, we set up silica tests before and after to make sure that our data collection is both precise and accurate. Now, I'm going to adjust these sliders over here until the image is relatively crisp. So, there we go. Just want to make sure I can start to see something. Typically people leave the zoom at the lowest magnification because it can get a little bit fuzzy. Oh, too far. Alrighty, that should work good enough. So one of the biggest things that you need to pay attention to and look at to make sure that you focused on the right surface is that when you move around, you can move around just using the left mouse button and whatnot, the image actually changes. So what would happen is if you focused on the lens, for example, you would just see like a stagnant image onto there because you're not actually moving anything and whatnot. So to start moving along here, what you can do is you can like I said earlier, just you can just left click, or you can hold and drag, and then it'll start moving it at faster velocities the farther away that you get from the crosshair here. Now, to start setting up the test locations, I'm going to try and find a place that is very minimal debris. So if you look, this is fused silica, so people do use it a lot to make sure that their tests are going correctly. So you want to try and get away from any surfaces, any part of here that has those indentation holes onto there. So here looks to be a pretty good place. So once that's all set, I'm going to go over to this section over here, and I'm going to set a project name. So I already set the project name as training video just to keep things simple. Now, to begin adding tests, what you're going to do is you're going to press this plus icon over here, and then you're just going to have to enter in some information about your sample. So this is fused silica, and then for a comment I'll put before testing. And then once you got that, you're just going to click on this arrow here to continue. Now it's just going to ask you about some operational parameters that you need to set before you start doing work on here, namely the Poisson's ratio of sample. So for fused silica, the number is actually 0.188. We have the system just preset it to that as the first one that you go to. And now for the test level inputs. So you know that there is the target load and the target depth. This one isn't as important as these other two over here. These parameters here essentially serve as the restraints of the test that you want to run. So typically you typically only modify one of them, and then you make the other one like an absurd number so that it doesn't get triggered. So let's say, for example, I wanted for the target depth to be 5,000 nanometers. So in order to allow for this to be the defining parameter, what I'm going to do is I'm going to adjust the target load and put it at the maximum value of 50 micronewtons. So obviously it's not going to reach 50 micronewtons, so the test is going to stop when it reaches this target depth of 5,000 meters here, 5,000 nanometers here. So I'm just going to click on there, and now we are actually at the test location spot here. So typically when you're setting up your locations, a lot of people just use the array over here because it allows for very easy, it's a much easier and faster way to just add test locations onto here. So let's say I wanted to perform 20 tests. So what I'm going to do is I'm going to create a 5x4 matrix, and I'll make the spacing a little bit higher. I'll make it 30 microns by 30 microns. Typically, you'll want to make sure that your markers are separated at least 20 times the indentation depth. So I'm just going to press OK, and then it has our array over here, and their XYZ coordinates have populated this window over here. So for the rest of these buttons, the plus icon here allows for you to add a single test location onto here. So let's say I wanted to have another test over here. I just press the plus icon, very easy, and then it just leaves a marker over there. It's represented as the 21st test. Let's say I didn't want to do that. I changed my mind. So I'm just going to press this minus button over here, and it's just going to completely get rid of it. Or even more so, let's say I chose a bad location for where I want this test to occur. If I want to just very quickly delete all of the test locations that are on here, I'm just going to press this C button, and then it'll just very quickly get rid of all of the points over here. But I don't want to do that for right now. So what I'm going to do is I'm just going to press this go over here and continue. Now we have our first sample set up. We have the fused silica. So over the next couple of minutes, I'm just going to go to the other pucks here and then just set up the rest of the samples. Alrighty, since now all the tests are set, the last thing that I'm going to do is I'm just going to go over here to this wrench icon and I'm going to click Engage Options. So I just wanted to make sure that the X and Y offset are put at -50 because you just want to make sure that your drift rate is set to the set strain rate. Alrighty, so now that that looks good, everything looks very nice. What I'm going to do now is I'm going to close the compartment of the Nanoindentor here. And then I'm going to click this giant play button over here and it's going to start taking data on the samples that I have. In the next video, we'll get into tip calibrations and graph formatting and pretty much figuring out how to interpret the type of information that you get from a Nanoindentor. So thank you for joining us and I'll see you next time.